Hello, my name is Ryan Davison. This is my interactive learning video number 4. So first of all, I drew a picture for the problem right here. It's up here. So this is Jane right here. This is the distance, 2 miles that she has to cross to the shore. We're going to make this distance from the shore to the finish, or the distance from the shore to the end of the hypotenuse, which is what we're trying to find right here, x, and we're going to make the distance from that point to the final point, 6 minus x. And so in order to find the hypotenuse, we're going to do a little bit of math. So we're going to use the Pythagorean theorem, and we end up getting c, the hypotenuse, equal to the square root of 4 plus x squared. And we're going to plug this into the formula here. So our total time is going to equal the distance divided by rate of the hypotenuse plus the distance divided by rate of this point right here, the one that we don't know, the 6 minus x. And so this is on the interval when x is greater than or equal to 0, and x is less than or equal to, is less than or equal to 6. So we're going to rewrite this and take the derivative. So we're going to take the derivative of this function right here, the square root of 4 plus x squared over 2 plus 6 minus x over 5. And we're going to rewrite it to make it easier to take the derivative of. So we're going to add 1/2 to that and 1/5. And we're going to take the derivative using the chain rule here, and we're going to end up with 1/4 times the quantity of 4 plus x squared to the negative 1/2 times 2x, and this becomes a negative 1/5. And with that derivative, we're going to do we can rewrite that. We can cancel out the 2's right here, so that this 2 will cancel out with this 4, so this will become 1 over 2. So this will become 1 over 2. And so we end up with x over 2 times square root of 4 plus x squared minus 1/5. And we're going to set that equal to 0. And when you set that equal to 0, you're going to want to square it. So you're going to subtract the 1/5. And you end up squaring it to get rid of the square root right here. So you end up with 4 times the quantity of 4 plus x squared equals 25x squared. And after that, you're going to multiply the 4 in. So you get 16 plus 4x squared equals 25x squared. And subtract the 4x squared over, so you get 16 equals 21x squared. And x squared equals 16 over 21. So x equals plus or minus the square root of 16 over 21. And we're going to use the plus because the minus is not within this range right here. So we can't use it. So it's going to be, and we can also simplify this down to 4 over the square root of 21. So we can use positive 4 over the square root of 21. And to find out which, this is our critical point. So to find out which point we're going to use to determine at what point she should cross, we're going to plug the points 0, the endpoints 0 and 6, plus our critical point, and see which one gives us the smallest value. So when we plug that in, when we plug in 0 first, we're going to get square root of 4 plus 0 squared over 2 plus 6 minus 0 over 5 equals, and that equals 2.2. And then we're going to plug in our critical point. So we're going to get square root of 4 plus 4 over the square root of 21. On that quantity over 2, plus 6 minus 4 over the square root of 21, that quantity over 5. And that equals approximately 2.15. And we plug in our last endpoint, 6, and get square root of 4 plus 6 squared over 2, plus 6 minus 6 over 5. And that's approximately 3.14. So we know that this one, our critical point that we found right here, is going to be the distance that she needs to cross at in order to make it the shortest time.